Hi, my name is Derek Baptista, and my advisor is Kevin Williams. For my senior project, I designed and manufactured two natural composite canoes. During my presentation, I'm going to talk about the problem statement, some goals and constraints, the milestones and coursework I used, a solution approach, followed by alternative analysis and recommendations, and lastly, a summary and future plans. So the problem with many canoes is that they're manufactured using non-biodegradable materials, and this can create a large carbon footprint. This also causes many harmful toxins to be released into the atmosphere. Some goals I had were to actually manufacture two canoes using natural materials, as well as show the feasibility and economic justification behind this. In doing so, I wanted to decrease the carbon footprint during the actual manufacturing process, as well as manufacture an economical canoe with the same strength to weight ratio as some of the high-performing canoes that are out there today. Some of the constraints I faced were the equipment and materials needed to manufacture my canoes. Some of these materials and equipment were very expensive and weren't readily available, so I had to find alternative methods of manufacturing these canoes. A second constraint would be the time required to manufacture. The specific resin I used had a pot time of 60 minutes and a cure time of 6 hours, so I had to find time throughout the day where I could do this without being interrupted. A third constraint would be the workspace availability. I actually made these canoes in a lab, so I had to do it after hours once the labs were done, so I wouldn't be interrupted and I could get it done in one shot. And lastly, cost was a big constraint. I wanted to keep the cost down because I'm trying to show that it's less expensive and more economical. So I was really trying to find materials that I could use that were a lot cheaper and economic. Some of the coursework I used was IME 303, or project management. I had to make a project plan with deadlines so I could keep track of where I was throughout the process and so I could stay on task. In the bottom right is a screenshot of my actual project plan with all the tasks and subtasks on the left and the Gantt chart on the right. A second class I used was IME 314, which was engineering economics. I definitely needed this class to show that there was a justification for why I was doing this canoe the way I was doing it. One of the reasons I'm building them is to show that with my materials and my process, it actually is more economical to do it as opposed to the current materials that are used. Thirdly, IME 319 and 429, which is human factors and ergonomics. I needed these classes to figure out seat height and adjustability, as well as the yoke and the thwart design. So in the middle of this canoe, you can see the yoke and the thwart. The yoke is used for when you're carrying the canoe on top of your head, and there's a little cutout right there so that you can rest it on your shoulders right by your neck, or right on your neck. And so I needed ergonomics to figure out what size that little cutout should actually be. And then thwart is used to hold on to something when you're carrying it. So I needed to know how far away I should put that. And then the seat design and height, it's mainly just the adjustability for the seat, because you don't want to be sitting too low or too high. So you want to just have that right adjustability and comfort for your own personal use. And then IME 326, which is it's a stats class, but I used it for design of experiments. One idea I had was to mass produce this, so if I was going to do that, I would need some standards of how I'm building it and how I'm doing the manufacturing process. So I definitely needed this class to figure that out. The solution approach I followed was first identifying the current materials used to make canoes. These include plastics, wood, aluminum, and even carbon fiber. Next, I had to research the natural materials with similar properties. After doing research, I found that some of these materials include flax, hemp, jute, bamboo, and balsa wood. And thirdly, I actually had to manufacture this canoe. And lastly, I had to do an economic justification and analysis. And on the bottom, you can see these are pictures of all these materials. On the left, we have flax, followed by the hemp, and then jute. And then these are all kind of compared to what carbon fiber looks like. So as you can see, the ones on the left, they all look pretty natural and sustainable, and clearly the one on the right, carbon, is not. So after building my canoe, I had to do an economic analysis, and I found that the demand forecast for 2016 would actually increase 8.8% to $6.6 billion. Now this is for the entire boat industry, so it's not specifically for canoes, but it still has a large impact on canoes and other boats in general. So if we look at the price of fibers per yard, you can see that carbon fiber is twice the price of hemp fibers at $28.5. And if you take that a little further and calculate the average cost of fibers per canoe, you can see that a carbon fiber canoe would cost $342 versus $171. So when I did the annual cost analysis, I had a couple variables that I had to figure out, and I found that the average cost of a canoe was $2,000 and the market demand was 3.3 million boats. So if you do all the calculations, you can see that carbon fiber and hemp fibers have a big difference in cost, and you would actually be saving $564 million. Now if we switch to hemp fibers and flax fibers and even jute fibers, this could really help our economy. Some recommendations I have, firstly, would be to educate the population of the importance and benefits of all these materials. Sustainable materials really do help the environment, and they save our country a lot of money. Also, finding alternative ways of creating natural canoes and accessories. I would say I need to do more research on finding different types of fibers and different materials to use, which maybe have stronger properties, maybe have better costs associated with them, but basically just doing more research on finding different materials. And thirdly, harvesting natural fibers domestically. This reduces taxes and tariffs. I found that the tariff rate for all natural fibers are 6% of whatever you're bringing in. So that alone could save the US a lot of money, and I found this actually on export.gov. So summary and future plans. I manufactured 2 canoes made from natural composites, as well as reduce the carbon emissions in the actual manufacturing process, and obtaining all these materials reduce the carbon emissions as well. And thirdly, I want to identify alternative materials that are natural and suitable for canoe manufacturability. This kind of goes into what I was talking earlier on finding materials with similar properties as carbon fiber, with similar weight ratios, to give you that performance and weight advantages. And that is the end of my presentation. So if you have any questions, please feel free to ask me, and I'll be more than happy to answer your questions. Again, my name is Derek Baptista, and thank you for listening.